In our next section, we will talk about some network topology architectures. The three-tier architecture, guys, consists of three different layers, and they are access layer, distribution layer, and the core layer. The core layer is in charge of fast routing simply, and it is the layer which is a gateway to internet or other sites. And the core layer also provides scalability and fast convergence, guys. When it comes to distribution layer, in this layer we have multi-layer switches capable doing routing also. And they have a high capacity and high port speed and density. And this layer aggregates the server access layer using stitches to segment workgroups and isolate network problems in a data center environment. And the last layer we will talk about is the access layer. We can use the layer 2 switches in this layer because we are not based on routing but in some MAC address forwarding just. The access layer is a layer that is used to grant user access to the network devices, and mostly on access layer switch we have some end user PCs, some printers, some IP cameras, and etc. IP cam and etc. Okay. So let's go ahead with the two-tier now. The three-tier hierarchical design maximizes performance, network availability, and the ability to scale the network design. Yeah, three-tier is really great, but many small enterprise networks do not grow significantly larger over time. Therefore, a two-tier hierarchical design where the core and the distribution layers are collapsed into one layer is often more practical. A collapsed core is when the distribution layer and the core layer functions are implemented by a single device. The primary motivation for the collapsed core design is reducing the network cost while maintaining most of the benefits of the three-tier hierarchical module. Now let's finish this session with the spine leaf. For a long time we have talked about Cisco's two-tier and three-tier network design, where we just talked about and we had the following layers: access, distribution, and core. The access layer connected to our end devices, such as clients and servers. However, within today's data centers, a new topological design has taken over, and it is called spine and leaf. So, imagine a cabinet in a data center filled with servers, guys. Frequently, there will be a couple of switches at the top of each rack, and for redundancy, each server in the rack has a connection to both of these devices. You might have heard the term top of rack used to refer to these kinds of switches because they physically reside in the top of a rack already. These TOR switches acts as the leaves in a leaf and spine topology. Ports in a leaf switch have one of responsibilities: one, connecting to a node, you can see in here, and second, connecting to a spine switch. You will notice in the topology on the screen that each leaf switch connects to every spine switch. You can see the leaf switches in here, and here we are connected to this switch, here we are connected to this switch, and here we are connected to this spine switch. So, as a result, there is no need for interconnections between the spine switches. Okay, you can see there is no interconnection between the spine switch, also the leaf switch as well. It is also interesting to note that the uplink connections from the leaf switches to the spine switches could be either layer 2 connections or layer 3 routed connections. By interconnecting your TOR data center switches in a leaf and spine topology, all of your switches are the same distance away from one another.